Hello everyone, I hope you're all doing well. It's been a while, so I decided to make a new video, and today we're going to have a look at some Linux malware. We're going to have a look at Recoby. The reason for that is that I saw this pop up on Malware Bazaar just recently. So here you can see a couple of samples have been submitted of this backdoor. And I had a look on Malpedia because I originally didn't really know what this malware is, and I found a couple of articles from 2022. So this malware seems to be active, or at least active again. If we look in here, it says that online stores running PhishPig software may now have the Recoby malware installed on the servers. So pretty recent, and I decided to take a look at it. I downloaded this sample here. I will provide the sample hash in the description of the video. And without any further ado, let's jump in. I have this already loaded into Ghidra. I've already labeled some functions, and I will just start at the entry point. So finding the main in Linux malware or ELF malware is, in my opinion, not that hard, because usually you'd see this libc start main, and the first parameter here is going to be the main function. Right, so this is a function pointer and it's going to point to the main function. I already labeled that to MW main, and if we come in here, you can see that this is pretty much, well, there's not much going on here. So what we have here is first this function. This is actually a system call. So what you can do is, I'm running a Linux machine, so I can just go man2, because it's on the 2 index of the manual pages, and then oh, sorry about that, it's actually on the 1 index, and then I can take a look at what these functions do. So you can see that this function is for programs wishing to detach themselves from the controlling terminal and run in the background. So this is going to be pretty much like a service. It's just it's called a daemon on Linux machines. Alright, so it's gonna do the system call, run the background, and then we're going into a setup routine. And the setup routine takes the argument vector. Now, coming in here, there is a stack string, and the stack string here is just gonna translate to this. So R0st, then the @ the pound sign, and the $sign. If you look at the code, you can see that there's first a check here if this global variable here is 0 or 1 or whatever. So it's going to check if it's not equal to 0. It's 1 in here, so this code down here is going to run, of course. If it's 0, then nothing's going to happen. This is just going to return 1, and that's it. So this might be, I called it maybe debug switch, which is a little bit inaccurate. Maybe it's something that ensures that the malware only runs once. That could also be. But the interesting part, which I want to focus on in this video, is actually this function that I labeled maybe config decrypt, because at least in my opinion, there is some interesting stuff going on in there, and it, as we will see, indeed contains the configuration for the malware. So for the rest of this video, we are going to reverse this config decryption, and then we are going to build like a quote-unquote config extractor for the configuration stored in the malware. Alright, so let's go through this here one by one. you can see here that I've labeled this var pointer const 0xc. So if we follow this global variable, I'm just going to do a double click on it. You could also hover, but I just do a double click on it usually on these globals and then go over to the listing view. You can see that this points to this address which contains hexadecimal C. So that is 12. And right below that there is something that I called data blob 0. So if we go back here, you can see that this data blob 0, sorry about that, just double click again, come over here in the listing view. So 12 bytes from here are going to be copied over to this variable. If we mark that, we can see it's a buffer with 254 bytes. So we're copying 12 bytes from this data blob over here, and then we come down to this function, and you can see that that we're actually using this this variable here, which we copied the data to, in this what I called mw maybe config decrypt. Now, what is going to be passed in is this data blob, this constant 0c, and this what I call XOR key, so this stack string. Let's check this out. Looks a little bit scary at first, but actually it's not that scary, which we will see. So coming in here, what it first does is it checks the arg size, which in our case was hexadecimal C, so 12. The buffer, which is the data that's copied over from this data blob, and then the XOR key. So it first checks if this if the size is even greater than 0. If it is, what's going to happen is that it takes this var buffer and it's going to zero it out. You can clearly see that here. It just starts at 32, and then while it's not 0, it's going to just decrement and set whatever the this variable, this pointer points to 0. So it's going to zero out this var buffer for us. Then we come down here to what I have labeled MW setup buffer. Come in here, and you can see the same thing again. So we have a buffer. This buffer is zeroed out, and then the work on the buffer passed in and this local buffer starts. So first of all, there is a function which I called MW set buffer number. It takes the buffer that is passed in as an argument, and it goes through each byte in the buffer. And here you can see it sets each byte to I, and I is continuously incremented until I is 256. So the buffer that is passed in here, this parameter 1, we can label that to arg buffer, is going to contain the numbers from 0 to 255 in the end. So we know what the first function does. And the next function, which I called MW init buffer with constant, is going to take the key and the local buffer. So let's have a look in here. First, this part of the routine. Let's go through that real quick. So you can see we have a pointer to the key, which is passed in as an argument. And this here is pretty much just going to get the length of the key. And this length is going to be saved in what I called buffer2 len. And then down here, it is going to take the buffer which is passed in as an argument and set each position in this buffer to a value or to a byte of the key. So if you look at this routine, we have the modulus operator here. What it's going to do is it's going to get the length of the key, and then it is going to set the 256 bytes of the buffer which is passed in to a byte of the key modulus the key length. So what this buffer is going to contain in the end is just the key repeated over and over and over again. Now let's go back. There's a better way to do this, but I just always push the back button. I don't know. It's just something that I do. So the next function in here is what I call the permutation. For me personally, I think that's a fitting name. And this is going to take the supplied buffer, which was filled with the numbers from 0 to 255, and the buffer that was initialized here, so a buffer which contains the key passed in, repeated over and over and over. Those are two arguments, and if we come in here in this permutation function, you can see something more or less interesting. So what happens here? First is this line here, line 11, and here an index is calculated. You can see that this index is set to 0 at the beginning, and what this function does is it's going to take a byte from the buffer 1 passed in, so that is the buffer containing the key repeated over and over, and from buffer 0, which is just the numbers from 0 to 255. So it's going to take 1 byte from this buffer, 1 byte from the other buffer. It's going to add the index to it and AND it with 0xFF, so just to keep it in the range of at most 255. That's going to be what's in index. And then what happens is it calls this function which I call MW swap. So swap is just really simple. It's just a byte swap. So it takes, let's just rename this, then you will be able to see it right away. It saves whatever's passed in parameter 1 to temp, then it sets parameter 1 to parameter 2, and then parameter 2 to temp, which contains what was in parameter 1 formerly. So it's just going to swap the two arguments. That's pretty much it. Alright, so this is going to swap the current byte pointed to in buffer 0 and buffer 0 plus the index, which was calculated up here. And then you can see this is just incremented. So both buffers are incremented. That means we're pretty much walking through all of the 256 bytes in the buffers passed in. So this is what I call permutation, as it does this swapping. Alright, so that's pretty much everything that happens here in this MW setup buffer. And if we go back to the config decrypt, we can see that the result is of all of these operations is going to be stored in var buffer. And then when we come down here in this part from line 24 to 36, we're going to have the actual decryption. Now, note one thing. I is initialized to 0 here, and as you can see here, the first thing that happens in this do while loop is that I is incremented by 1. So if we have a look at the part down here, so this I is going to be stored to what I called II, and this is going to be the index for the buffer. So we start counting at 1. That is something to keep in mind, so we don't have an off by 1 error when we build our config extraction. Now, this index is initially set to 0, and again, it's just made sure that it stays in the range of 255 here. Then we're going to do the same thing as we saw before. We're going to take the buffer plus the index, and the buffer plus I, so starting at 1 to 256 or 255, and we're going to swap that with the buffer plus the index that's calculated up here. And then in the end, what you have is you just have this pointer to the buffer that was passed in. So here, this, and that was the copy of the data that's in stored as a global, this data blob. And then we're going to XOR that, do a couple of calculations here. This is just going to be the buffer that was set up here is going to be indexed. That's this plus here by the buffer plus II, and then the buffer plus index. So we'll see that later. It's pretty much just a little bit of moving stuff around. Okay, so if this isn't clear at the moment what's going on here, we're going to walk through this step by step when we do the config extractor. When I initially reversed these routines, I programmed them all in C, but I decided to go for Python in this video because it's just a little bit, the syntax is well, not the syntax, but I can make a shorter program. That's the idea here. Okay, so let's jump over to Visual Studio Code, and then we're gonna program this extraction. Alright, so now we're in Visual Studio Code. I am just going to increase the font size so it's easier to read. Just let me do that here. I'm gonna do 18, I think. Yeah, that's much better. Alright, let's go. First of all, let's do a if name is equal to main. And then we're gonna call the main function. And this main function, we're gonna define it here. And for now, we're just gonna pass, so we're not gonna do anything. What we need now is something to read from the elf file. So what we're gonna do here is we are gonna say from elftools.elf.elf file, and then we're gonna import elf file. If you don't have elf tools, you can just install that with pip, and you should have everything you need. Okay, so next thing here in the main is we are going to have to read from the sample, and to do that we are just going to go ahead and write a little function that does that for us, and we're going to call it readelf. So, or yeah, let's just call it readelf for now, and this is going to return some bytes. Now in here, I am just going to declare something that's called a data section, and I'm going to set that to none and open the elf file, and that is going to be done via the open function. So we're going to open the path that is given to us, and then we're going to do read bytes, and we're going to do that with asfp. Then we can just get the elf file by using this class here and passing it the file pointer, and this is going to produce the elf file for us. So here we can iterate the sections, and we can do that by elffile.iter.sections. I'm going to pass here and just finish this, and this is going to return the data section. Again, we're going to finish this up in a second. Just do all of the prep work first. So I'm going to call this data, and this data is going to call readelf, and this is going to read the file here for us. So let's just do ls-l and copy this out and throw it in here. Alright, now what section do we read? If we come back in here, we can see that this data blob is, if you just hover over this, you can see that it's in the section data, so .data. This is what we're going to need. Okay, so let's go ahead and extract the data section. For that, I'm going to go really simple. I'm just going to check the section name. So if the section.name is equal to .data, then we're going to do data section is equal to section.data. And this is going to give us the section data as bytes. So when we've got that, we can break. And here I'm just going to put in a little print, and we're just going to do got.data section, so we know that we've actually hit this. And then we can do Python 3 extractor.py, and here you can see the first error that I made, because this is not a dot, this is an underscore, of course, and here we have got.data section. Now we have to do a little bit of work, a little bit of additional work. And if you look at this, the problem is that there are all of these, or rather not a problem, but something that that we can use to our advantage is that there are null bytes in here. So let's go to the start of the data section maybe, and this is, I think, data blob 1. So let's just go up here. All right, that was too far. So here the data section begins. It's hard to read, but this is the beginning of the data section. Then you can see there are all zeros in here. Then we have this 2C. Then again we have some data. Then we have all zeros, and so on and so forth. So there's actually a second data blob in here, and this here is the data blob size. We're not going to need that, because once we pull the actual data out, we can calculate the length of the data after removing all of these zeros. So all we're pretty much interested in is the data itself, so we can throw away the length. And in this malware, we can use the structure of the data section to our, as I said, to our advantage. So we throw out all of the nulls here, we come down here, there's a null again here, so we can throw that out, and then the same goes for the other data blob. So that means we're only concerned with what is not null and with what has a specific size. And we can achieve that by taking the data, and we're gonna do a data.split, and we're gonna split at null. And if we now print data, you can see that you get a whole bunch of nulls, and then just some data, right? That's what you get. And what we can do now is we can actually go ahead and say we're only going to take the stuff that's greater than null or greater than 0, because we don't care about these empty byte strings. And we can do that by just saying data is equal to list, and then filter. We're going to do a lambda expression in here, so x, and then the length of x is greater or equal to 1, and this is going to be applied to data. And now if we print this, you can see that we actually have this cleaned up pretty nicely. Now what is going to happen is that we're going to have 4 elements in this, I guess, in this list, and as you saw before, we can just write this down. So data 0 is going to contain the length for blob 1. Data 1 is blob1 data. And that was followed by this, what I called the debug byte, or the run once byte. And this is going to be contained in two. So this is going to contain the debug bytes, just put that in quotes, plus the length for blob0. And data3 contains blob0. So this here is 12 bytes, and this is more than 12 bytes something. That means what we can do here is just say, okay, if it's greater than 4, and then we should have this nicely filtered out. And now you can see we have exactly the two sections that we're interested in, or the two parts that we're interested in, and that is these two blobs. Now we can remove this, and we can remove this, and now we have the data. Now on to programming the decryption. I'm just going to make a new function called def decrypt here, and this is going to take in data and of course the SOR key that we need. If you remember from before, we had two buffers. The first buffer, we're just going to call it buffer 0, was just all of the numbers from 0 to 256. And we can do that by this here, by this list comprehension. So we're just going to take a range, and we're going to iterate through that range, and we're going to put the value into a list. So that means we're going to get a list from 0 to 255 as an output from this. Now the next part was where the second buffer that we set up, or that we saw in the malware, it just took the SOR key and then it just put it in a buffer, concatenated it, so it filled the buffer up with the SOR key repeatedly. And we're gonna do that by declaring a buffer1. And I did it in this way. I just said, okay, make a list out of SOR key, and just multiply that by 256, do an integer division, and then we have the SOR key here. So now it's going to take this 256 divided by the length of the SOR key as an integer division, and then replicate this SOR key this many times, put it in a list. This is not going to give us the correct result because the SOR key actually has an odd length. So that means we're going to have to add something additionally, and that is just the remaining bytes of the key to get up to 256. So we're going to do a list SOR key, and then here we're going to do 0 to the 256 minus the length of buffer1, and this is going to give us the remainder that we have to fill in. Now if we print buffer1, we can check if all of this is correct, and we're also going to do a print buffer0, and down here we're going to pass in the SOR key, which we haven't yet extracted from the malware. Now this is the part where I said before we're going to do a quote-unquote config extractor, because I haven't figured out a nice way to pull the SOR key yet. So we're going to put this in manually. That means if this key changes, that the config extraction will actually fail, so beware of that. And we're going to put this into a Python byte array, or Python byte string, I think it's called correctly. So for that, I'm just going to edit this real quick. We're going to start at the beginning, up to the equals sign. We're going to remove all of that, and that should be that. Forgot that one up here. we can get rid of this, and then we're gonna just remove all of the new lines. So we're gonna replace this here with a comma, and now we should be good. Let's also, oh, sorry about that. Let's also replace this here. So we're gonna do the 0x. We're gonna replace it with an x, and just do that for the whole line. And now we're done. We have our sort key. No semicolon. So this is our sort key, and we can pass that into Decrypt. So data 0 here, and then the sort key. And then we're going to run this. Alright, so here you can see the first buffer contains, indeed, as we wanted it, the numbers from 0 to 255. And this is the sort key. I'm not gonna go ahead and actually convert this to hex, because we can clearly see it's repeating, and that is exactly what we wanted. So now let's check the buffer length if it is correct. We're just going to run that, and it's 256 bytes. So we're good here. We have set up the two initial buffers, and now we can do this buffer permutation that you saw with the index and the swapping of bytes. So let's do index is 0, and then here we're going to go from 0 to 256 in range, and then we're going to calculate this index. As you remember, this was just buffer 1, the current byte in buffer 1, and the current byte in buffer 0, plus the index, and then it was just ended with 0xFF. So that was, if you remember, in setup buffer, this permutation, and you can see that we just coded this line. And now we have the swap. So let's just do a swap, and this was buffer 0 I, comma buffer 1 I, or index, sorry. Yeah, that was buffer 0 and then buffer 0 plus index. So we're going to swap those out. Alright, and this is going to be equal to buffer 1 index, comma buffer 2 I. And let's just mark this. So this is the swap of the two values. And that's it. We have the buffer permutation. So this is buffer 0 setup to ascending, or to 0 to 255. Then we have this, I'm going to call it expand the sort key to 256 bytes. And in here we have the permutation step. Okay. Now, once we have this, we can do the actual decryption. And this decryption was, let's see, this part down here. Right, so we have a couple of things going, and that is that we have another for loop. We're going to reuse this index variable, and we're just going to say for I in range. And remember, here we started from 1, not from 0. You can see that here, because I is incremented before it is used, and then it is set to this II, as I called it. So we're going to go from range 1 to the actual size of the data that we want to decrypt. So here we can just say len data. And that's why we can throw away the lengths that we saw in the data section. before, because we don't need them in here, we can just use length data. So we were able to throw the length values away here. Okay. Now let's get the index, and that was buffer 0i plus index plus 0xff, or sorry, this should be an AND. So that was this line here. We get the current position in the buffer starting from 1 plus the index, and we're going to AND it with 255. That's the part down here. Now we're going to do another swap. So let's call it as that, swap. And the swap is going to be, let's just take this up here. The swap is just going to concern buffer 0 this time. We're not going to use buffer 1. So we're going to do the swap here. And that is this line. As you can see, it's going to swap what's in the buffer that was prepared for us up here. And it's going to swap position I or II with the index position of the index that was calculated up here. So we're going to do that here. And now we have the swap. And now follows the part which we can see here. So it's going to take a pointer to the data that was passed in as an argument, which is the data blob, and then it's going to take the current position. So it's going to just increment this by 1 in each iteration of the loop, and then it's going to XOR it with the buffer that was set up here. And this buffer is going to be indexed by the value at position II and the value at position index. So that's what you have here. Note that there is a cast here. The cast is actually before a cast here, which just keeps this addition value in range. No problem if this is a little bit confusing. We're going to see it in Python, and then it's going to be way easier to understand. So first of all, let's go ahead and calculate this offset into the buffer down here. So we're going to call this value, and it's going to be buffer 0 at position I plus buffer 0 at position IDX, which we saw here. Buffer plus II, buffer plus IDX. And we're going to use this to index into buffer 0. So here we can say the value which we're going to use in the XOR operation is going to be buffer 0. The index is value, and of course we have to keep this in the range of 255, so we're just going to AND it. We're going to truncate. And now we are just going to take the value from the data blob, and we're going to XOR it with this expression which we got from the buffer. So let's do that. This would be just the data value, but I minus 1, because here we actually start at 0. If we come back into the malware, we can see that, and we can just see that by following the data that's passed in. So var pointer data points to the beginning of the data blob, or the copy of the data blob, that is, and that means index 0, and this is incremented by 1 in each iteration of the loop. Whereas this I, which indexes into the buffer that was set up, actually starts at 1. So we have to take that into account. And here it's pretty easy, because we're just going to take I and subtract 1 from it, and then we're at the correct position. Because we're going to start at data 0, then it's going to go to data 1, and so on and so forth. So that that should keep us in the range we want to be in. And here we're just going to XOR it with this variable that I called XOR. Now we just got to put that result somewhere, and I'm just going to make a list here, and then we're going to say res append. We're going to just cast this to a character so that we get a list of characters, And with that, we should be good. And that is it. We have buffer 0 set up, this quote-unquote key expansion, this permutation step, and then we have the actual decryption. And now we can just return the result, and we're just going to join the values of the list together. That should be it. So this is decrypt 0, and now we're going to print that out and see what comes out. AKA, we're going to see how hard I failed. Yeah, and I failed hard. Yeah, I made a silly mistake. So the first mistake, as you saw, was in here, that I actually did the swap with buffer 1 with app position index. And the second silly mistake was that I'm so used to C programming that I actually separated these by a comma, which in Python that's not going to work. So that was the problem. That means we can get rid of this and then pass in the two blobs and hopefully decrypt correctly now. Alright, so let's save this, and then we can just go ahead and run this. And as you can see down here in the terminal now, we have an IP address with a port. We have what looks like a separator, like this pipe symbol is a separator. And I'm just going to copy this out and put it in VS Code. Then it's a little bit easier to read. Just a sec. Let's put this in here. Alright. So you can see that the first part that we decrypted is an IP address with a port. Then these pipes seem to be separators. And I saw something in the malware that was like, that was getting timestamps. So the 0 to 24, don't know, might have to do something with time. And these could be some configuration options, like just flags being set. And then we have this user bin SS, which might be something that is overwritten, injected to the process could be renamed to that, whatever. So this is the configuration. Now, apart from the SOR key, this extraction should be pretty general. So we succeeded in reversing the encryption algorithm for the configuration, and we sort of wrote a config extractor in Python so we can automate the process to get the configuration out. Now, the SOR key here is the problem in this implementation. This is not automatically taken from the malware, so this would be something that would have to be done to fully automate this. For my purposes, I think that reversing this encryption algorithm is it's pretty much sufficient. I have to look into the best way to actually get this key out of the malware, so that the extraction doesn't depend on the key, which it does at the moment. But yeah, I think we've covered quite a lot of ground here. You saw that with these ELF tools we can read the data section. I showed you the decryption algorithm, and we reversed that, just wrote it down in Python. And now if you just supply the file, then the extractor will actually get the decrypted sections out for you. Okay, so with that being said, I think that's it for this video. I hope you took something from it, and yeah, as always, I hope you had a fun time watching, and I will see you around. Goodbye.